Okay, so for part 2 of today's lab, you're learning how to set up a force, to write a force diagram, draw a force diagram, and then use Newton's laws of motion to analyze a situation. So here's a situation. So there's a frictionless track here, right? And here's a frictionless massless pulley. Here's a mass M1 connected to a horizontal string, mass M2. No friction. We're ignoring all friction. And so what you're going to do is you're going to hold on to this, attach everything, and then let go. And so it's going to go like that, right? And so you have to draw the force diagrams to two objects. You have to draw the two force diagrams, and then use Newton's laws of motion to calculate the acceleration of the system. Because it moves as a system, right? All right. In other words, this has the same acceleration as that. So that's what you have to do, calculate the acceleration. Now, so you'll do that, and then I guess two of the questions in the lab handout, they say this. What's going to happen to the acceleration if M1 is much, much larger than M2? So if you've never seen this before, this is two greater than signs. It just means much, much greater. Or I like to say tons greater. There's also a much, much less than. Okay, so like I said, there's one question that says, what's going to be the acceleration if M1 is tons bigger than M2? Another question, what's going to be the acceleration if M1 is tons less than M2? Now, you have to solve it mathematically, but before you do that, I just want you to think. Let's do this one. If M1 is tons greater than M2, so M1 is a big hunk of titanium or something like that. M2 is a piece of tissue paper. What's going to be the acceleration? I'm not going to tell you. You figure it out. It's pretty simple, right? Okay, let's do the other one. What happens if M1 is tons less than M2? So now this is the titanium, and this is the feather or a piece of tissue paper. What's going to be the acceleration? So again, you should know the answers just by what you've learned in physics so far. All right, so that's all fine and good, but now we want to prove it mathematically. So I'm just going to give you an example so you know how to do it. Okay, in astronomy, we often have a situation where we have a star that's being orbited by a planet. So M1 is the star, M2 is the planet. Now, generally speaking, the star has a huge mass compared to the planet. So generally speaking, we're going to have this. The mass of the star is tons bigger than the mass of the planet. Okay, now what we want to do is we want to figure out the mass of the star. Now how do you do that? I mean, you can't go up and put the star on a balance, right? It'll burn, right? I mean, you can't. How do you do that? So this is what I'm going to show you how you do it. All right, so this is a formula that you learn in astronomy. So this is T is called the period. It's the time for one orbit. A is kind of like the radius. Uppercase G, you already know. Then I have the masses. Okay, now let's use this fact to figure out a way we can calculate, or I should determine the mass of the star. Okay, so M1 is tons bigger than M2. So what you do, you divide this by the larger one. So the larger one is M1. So divide by M1, divide by M1, and then you got to compensate for it, right? So you multiply by M1. All right, so what have I done? Nothing. I've multiplied top and bottom by M1. I've multiplied by 1. Okay, now why did I do that? Well, you'll see. Okay, so what's M1 divided by M1? It's just 1. So that's 1. Now here's the important one. If M1 is tons bigger than M2, what's M2 divided by M1? In other words, what's 1 like over infinity or just something really, really big? What is it? It's like 0, right? If M1 is much, much larger than M2, this is basically 0. So this is 0. All right, what's 1 plus 0? 1. So I just have a 1 here. Well, that's stupid to write it like that. Let's just do this. Just G. Okay? So that's what happens to the denominator. Now, here's the beauty of it. If you're an astronomer, you can measure with your telescope the period, right? You can measure how long it takes for the planet to make one orbit around the star. So you can measure that. Okay, A is like I said, is like the radius. It's related to the radius. You can use your telescope to measure that. G is just a constant. Everybody, it's a constant of nature, so everybody knows that. It's a gravitational constant in Newton's law of gravity. So look, if you know everything except for this. So that means you can just solve for this, and bingo, you're done. So that's how people actually determine the masses of the stars. So you'll have to do something like this for this situation and that situation. And when you do it, make sure that your mathematics agrees with your common sense. Thank you very much.